Welcome to this video on IQR, upper and lower fences, and modified box plots. In this video, you will learn how to find the IQR, you will learn how to calculate upper and lower fences, and how to create a modified box plot. In the last video, we learned how to construct a box plot from a 5-number summary. Both the summary and the box plot are shown here. However, this box plot is not a modified box plot as it does not indicate the presence of outliers. Let's use the same 5-number summary to learn how to create a modified box plot. To construct a modified box plot, we cannot simply draw the box plot differently. Instead, we have to first identify the presence of outliers in the dataset. We do this by calculating the upper and lower fences. Any data points inside these two fences are not considered outliers. Any data points outside of these fences are considered outliers and must be represented differently on a modified box plot. The equations for the upper and lower fences are given below. Check with your instructor to find out if you will need to memorize these equations or whether they will be given to you. What does IQR stand for in these equations? IQR stands for Interquartile Range. The interquartile range, or IQR, is another way to measure the spread of a set of data. Unlike standard deviation, the IQR is a resistant measure of center and is not sensitive to the presence of outliers. The IQR is the width of the middle 50% of the data. It can be calculated using the formula Q3 minus Q1. Since the IQR does not include the top 25% or the bottom 25% of the data, it does not include the outliers, and that is why it is a resistant measure of center. Let's calculate the IQR, or interquartile range, of our dataset. Remember, IQR is Q3 minus Q1. In this case, Q3 is 26 and Q1 is 22. Subtracting those numbers, we find out that our interquartile range is 4. Now we can calculate our upper and lower fences. Remember, the equation for the lower fence is Q1 minus 1.5 times the IQR. Remember, our Q1 is 22, and we just calculated our interquartile range to be 4. At this point, sometimes students forget what they know, which is order of operations. Let's review order of operations. Please excuse my dear Aunt Sally. That means that we have to first do parentheses, exponents, then multiplication or division from left to right, finally addition and subtraction from left to right. So look at this equation. Do we need to subtract first, or do we need to multiply first? Pause this video and answer out loud, then unpause to see if you are correct. If you said that we need to multiply first, you are correct. So 1.5 times 4 is 6, and 22 minus 6 is 16. Again, if you forget order of operations, you will not be able to correctly calculate your upper and lower fences. Let's now calculate our upper fence. To calculate the upper fence, we need the equation for the upper fence, which is Q3 plus 1.5 times IQR. Our Q3 is 26, and our IQR is still 4. Again, remember your order of operations. So we have to do our multiplication or division before we can add or subtract. That means we have to evaluate 1.5 times 4 first, and then we can add that to 26. So our upper fence is 32. So our lower fence is 16, and our upper fence is 32. So what does that tell us? Well, that tells us anything between 16 and 32 is not an outlier. But any value in our data set that's less than 16 is considered an outlier, and any value greater than 32 is also considered an outlier. So let's look at our data set to find out if we have any outliers. So here's 16. You can see that our lowest data point is 19. So we don't have any data values in our data set that are lower than 16. What about our upper fence? Our upper fence is 32. Hopefully you can see that 33 is larger than 32, so it is considered an outlier. So we have this new information that we're going to add to our 5-number summary, which is that we have this outlier of 33. We're going to use that new information to construct a modified box plot. Please note that to create a modified box plot, you don't need to know where the fences are, only the outliers. Now, of course, you can't know whether there are outliers until you know where the fences are, but once you find the outliers, you don't need the information about fences anymore. Let's see what that means. So, just like last time, we're going to need a number line that starts at or before the minimum value. Then, again, we're going to draw the minimum and maximum values on the number line using dots. And again, it is common practice to label these so that a person reading your box plot doesn't have to guess where exactly these values lie, especially if they land in between tick marks on your number line. Now we need to represent Q1, Q2, and Q3 as vertical lines on the graph. And then we connect these 3 lines with 2 horizontal lines to form a box. You might notice that if you watched the previous video, everything that we've done so far is exactly the same as what we did to create a regular box plot. The process doesn't change until we get to drawing the whiskers of our box and whisker plot or box plot. Before, you might recall that our box plot looked like this. Now it's going to look different. We can still draw our left whisker in the same place because there are no outliers to the left of the box. However, there are outliers on the right side of the box. The outlier 33 will be represented by a dot which will not be connected to a whisker or a line. We still need a whisker extending from the right side of the box. The question is, how far does the whisker extend? Most people guess that it extends to the fence, which is in this case is 32. However, that is not the case. The lower and upper fences are completely invisible in a modified box plot. You never draw the upper and lower fences. The only way you know the fences are there is because you can see dots, which represent outliers. So how far does the whisker extend from the right side of the box? The correct answer is the whisker extends until the last data point that is not an outlier. Let's revisit our original data set to find out what this value is. Our upper fence is 32. So the last data set inside of our fence is 30. Therefore, we draw a line from the right edge of the box at 26 to 30. And that's it. That's our modified box plot.